Hi class, we are now in the last section of chapter 11. This is Solution Stoichiometry. In chapter 7, we used balanced equations to answer questions of how much. The first step in most stoichiometry problems is to convert the amounts to given moles. Convert the amounts given to moles. When working with solutions, we commonly know the concentration and the volume of a solution. Sorry if you hear the background noise, that's my dog digging on a quilt. From this, we can determine the moles of solute present. Once we have done this, we can predict the number of moles of any other species consumed or produced. Yep, hold on, there we go. Okay, so let's begin with an example. Silver and chloride ions react as shown in the following ionic equation. Based on this, how many grams of silver chloride precipitate could be produced if 10 mils of solution containing 0.0023 molar chloride ions reacts with excess silver? So this sounds very complicated. It's not really as complicated. It's just, again, this is probably new. So, and there's a lot of words, but break things down and then you can start pulling stuff out and you'll find that it's not really as complicated as it sounds. So, we are given the volume and the molarity of the chloride ions. The volume is 10 mils or 0.010 molar. You can see that's the first thing. So you see we have the balanced equation and we're looking right here. The molarity is 0.23 moles per liter. In order to solve this problem, we must first find the number of moles of chloride ions present. So the moles of chloride is equal to the molarity times the volume. So we plug those in, and that's what you're seeing here. So we plug that in so we can see, and now we have the moles of chloride ions. The liters cancel, and we give an answer of 2.3 times 10 to the negative 5 moles of chloride ions. Now that we have the moles of chloride ions, we can relate this to the moles of silver chloride using the balanced equation, and then the grams of silver chloride using the molar mass. And the molar mass is 143.2 grams of silver chloride. We begin with 2.3 times 10 to the negative 5 moles of chloride. From the balanced equation, we can see that we get 1 mole of silver chloride for every mole of chloride. The moles of chloride cancel. We then multiply by the molar mass of silver chloride, and the moles of silver chloride cancel. This gives us a final answer of 3.3 times 10 to the negative 3 grams. So hopefully this makes sense of how to pull it out and how to get the steps. This is a good problem to try to make sure you figure out exactly what all these steps are, but it's really only 2 steps. It's the first steps of determining the moles, and then it's a step of getting the mass of silver chloride. So it's not overly difficult. It just seems like probably that in the beginning. Okay, so to determine the concentration of ions in solution, chemists often use techniques called gravimetric analysis. In this technique, the mass of a precipitate is used to determine the concentration of the reactant. For example, suppose a chemist needs to find the concentration of iodide ions in a solution. How to do this? Recall that iodide ions react with lead-2 ions to produce lead-2 iodide as an insoluble precipitate, and you can see from the reaction right there. So let's take a look here. To determine the iodide concentration, we perform a 4-step procedure. First, take a small sample of the unknown iodide solution and carefully measure the volume. Second, combine it with a second solution containing an excess of lead ions, causing a precipitate to form. Third, collect the precipitate by filtration and allow it to dry. Fourth, measure the mass of the precipitate. From this mass, we can determine the number of moles of iodide present and therefore determine the concentration of the original solution. So let's take a look at a problem. The concentration of sulfide ion in a solution may be measured using precipitate reaction with barium chloride. The net ionic equation for this is, you can see there is the barium ions plus sulfate ions produces barium sulfate as a solid. You need to measure the sulfate concentration in a large drum containing aqueous sodium sulfate. From the drum, you measure 0.200 liter sample and react this with excess barium chloride. The reaction produces barium sulfate as a precipitate, which you carefully filter and dry. The barium sulfate precipitate has a mass of 0.309 grams. What is the concentration in molarity of sulfate ion in the drum? In this question, we are given the mass of barium sulfate and asked to find the concentration of sulfate ions in the drum. In order to do this, we must convert from grams of barium sulfate to moles of barium sulfate, then relate that to moles of sulfate, then solve for the concentration. We begin with 0.39 grams of barium sulfate. We convert to moles using the molar mass, which is 1 mole of barium sulfate per 233.39 grams of barium sulfate. The grams cancel. Next, we convert to moles of sulfate ion using the balanced equation. We use 1 mole of sulfate for every 1 mole of barium sulfate. The moles of barium sulfate cancel, and it gives us an answer of 1.32 times 10 to the negative 3 moles of sulfate. We now take this number that of sulfate present and the 0.200 liter sample to find the molarity, which is moles over liters, and that gives us 6.60 times 10 to the negative 3 molar. So hopefully this is another problem that may seem overwhelming, but really you guys have been doing these steps already. You just got to pull the information out. Okay, so as we explored stoichiometry over several chapters, we developed strategies to get from and to a number of quantities. The mole is essential to nearly all of these conversions. Most problems in chemistry involve conversions to moles at one or more steps. This image shows the map for showing a wide range of problems. For example, let's look about the reaction that takes place when a solid sodium bicarbonate, which is baking soda, is added to aqueous HCl. For this equation, a huge number of questions can be asked. For example, given the moles of sodium bicarbonate, how many moles of water are produced? This question asks us to convert from moles of one compound to moles of another. Here's another one. Given the molarity and volume of HCl, how many grams of CO are produced? This question asks us to convert from solution of HCl to grams of CO2. To do this, we need to go through moles of HCl, then convert to moles of CO2, then convert to grams from there. We could ask many similar questions. Each of these questions can be solved using this map. In fact, it is a good exercise to take a chemical reaction like this one and make your own list of questions that relate to the amounts of each component present. Oh, sorry, I didn't see that they had this with it. I missed this. Okay, so here's the problem. Let's look at a sample problem here. Calcium metal reacts with aqueous hydrobromic acid to produce calcium bromide and hydrogen gas, as shown in the equation below. What volume of 2.5 molar aqueous HBr is required to produce 200 liters of hydrogen gas at a temperature of 298 Kelvin and a pressure of 1.20 atmospheres? So this reaction gives us the volume of hydrogen gas at a particular pressure and temperature. Then ask for the volume of hydrobromic acid solution necessary to produce it. In order to solve this problem, we must begin with the volume of hydrogen gas and end with the volume of HBr solution. In order to get there, we must go through moles of hydrogen and moles of HBr as shown here. To go from volume of H2 to moles of H2, we must use the ideal gas law, which was covered in chapter 10, which is the N equals PV over RT. So if we do that, which is not shown here, but you should understand that we're solving with this one. So it would be, you plug in everything that is given here. And what you're solving for is the moles. So you're going to, if you can imagine, bring this down here, and it's going to be N is equal to PV over RT. So pressure is going to be 120 atm. Volume is going to be 200 liters of H2. Then we have our gas constant, which is 0.0821. And the temperature is 298. That's going to give us the amount of moles. And when we get the amount of moles, we can cancel everything, and that's going to give us an answer of, let me see, hold on. I apologize. I just realized that this does not match it. So I'm going to go through and talk about it, and then I'm going to fix this when I upload it, so the slides will actually match the problem. Okay, so we have a balanced equation, which you see is up here. This matches. This down here does not match this problem. The moles, so basically the moles of H2 are going to cancel. So we're going to use the PV equals nRT, which is right here. We end up with getting understanding the moles of H2. We use the balanced equation, which is just dimensional analysis stoichiometry now, to determine, once we have the moles of H2, we can figure out the moles of HBr. And then from there, we can then figure out, using the molarity equation, it will cancel out the moles and leave us the volume. And that I will fix all of this down here to show exactly what I'm talking about. Sorry about that. Some of this stuff is, I didn't catch that. Okay, so let's do some review here. If 250 mils of a 0.100 molar calcium bromide reacts with excess potassium phosphate, how many grams of solid calcium phosphate will form? Fill in the circles below to show the intermediate steps and then solve. So here is the answers. You have molarity and volume. You go to moles of calcium bromide, then the moles of calcium phosphate, and then you have your grams of calcium phosphate. So again, this is giving you 250 mils, which is now converted to liters. You have your molarity. That's going to cancel out, leaving the moles. Now you have the moles of calcium bromide, and you can do the stoichiometry. So you have calcium bromide and 1 mole of calcium phosphate. You have the molar mass of calcium phosphate, and it gives you the answer, which is 2.58 grams. Gravimetric analysis, use the mass precipitate to determine the concentration of reactant. So in a sense, you're working backwards. The concentration of chloride ions is determined by gravimetric analysis. A 0.500 liter solution containing chloride ions was reacted with an excess silver. The solid silver chloride was filtered, dried, and found to have a mass of 0.0027. What is the molarity of the chloride ions in the solution? So in this case, we take the mass, and we want to know the mass of the chloride ions. So we take the mass of the solid, which is silver chloride, we get the molar mass, and then we do a 1-to-1 ratio. So you can see we have 1 mole to 1 mole of chloride ions, which is what we get here. Now we're given the volume, and we plug that in there underneath, because that's going to give us our molarity. And the answer is 3.8 times 10 to the negative 5 molar. If 150 mils of 0.100 molar sodium sulfate is mixed with 300 mils of 0.150 molar lead nitrate, how many grams of solid lead 2 sulfate will form? This sounds like a very difficult problem, but it really isn't. There's only one thing I need to explain here. So first thing I would do is make the balanced equation. So you have the sodium sulfate, you have your lead nitrate, and you have the solid. And what it's asking for is the mass of this. So you're given the volume, and you're given the molarity, you're given the volume, and you're given the molarity. So what I'm going to do, what I did here, is because we're interested in the sulfate, because that's going to make that's the anion part of the compound of the solid. So I'm not interested in the sodium. So in here, this is my moles of sulfate that comes from this equation of setting this up with moles over liters times by liters, cancels out, gives you the moles. For here, I'm interested in the lead only. So again, I do the same thing. I set this up with liters, multiply it by moles over liters, the liters cancel out, and it gives me 0.45 moles. I need to know the amount here. Now, this is the one part I want to stress. You have 2 different amounts. So only one of these is going to be used up, and one's going to be in excess. So this is a limiting reactant problem. This is on the more challenging side of, I think, one of the harder problems. But so which is going to produce the smallest amount? This one. So you're going to set it up with 0.15, and then you're going to do stoichiometry to determine how much. So we start with this. We have 1 mole to 1 mole. We use the molar mass of lead 2 sulfate, and it ends up producing 4.548 grams, which ends up being 4.55. We couldn't use this one because this is going to run out well before this one does. So we'll never get to the amount that this one is. And that's the one thing I want to point out with this problem is it's rather on the challenging side. I probably would not give you a problem this difficult, but it's here to, they've given me this, so I want to show it to you. I didn't pick the homework, so I don't know if there's a problem related like this to the homework, but if it is, you now have the skills to do it. Aqueous sodium carbonate reacts with aqueous magnesium nitrate to form solid magnesium carbonate. What volume of 0.11 molar sodium carbonate is required to form 0.500 grams of solid magnesium carbonate? Again, pull out the problem, and when you pull out the problem, I tend to write everything underneath. So it tells me I need the molar, but I need the volume. It's telling me I have this much to start with. So I'm going to pull this out first. I'm going to get the molar mass. I have magnesium carbonate. I want the moles of sodium carbonate. So I get to my moles of sodium carbonate. I have the molarity. So I'm going to set moles over the molarity. That's going to cancel the moles out, and it's going to give me the volume, which is 0.593 liters of aqueous sodium carbonate. When zinc metal reacts with hydrochloric acid, it produces zinc chloride and hydrogen gas, as shown in the equation below. What volume of 6 molar hydrochloric acid is necessary to produce 420.3 mils of hydrogen gas at STP? This is similar to the problem that I have to correct that did not show the same the information needed, but this one does. I did do this one. So again, we're going to set up N, which is moles. I'm going to take all the information I need in here, which is at STP. So you guys hopefully remember what STP is. It's at 1 atm and 273 Kelvin. I take the volume that it gave me and my gas constant. It tells me what my moles of H2 are. Now, excuse me. So it's telling me what volume of 6 molar hydrochloric acid is necessary to produce this amount of hydrogen gas at STP. So I take my moles, and now I'm going to do a ratio. So I have my moles, and it's 1 mole to 2 moles of HCl. So I now have my moles of HCl. I also have my molarity of HCl. But this wants to know how much the volume is. So I set it up again. The moles will cancel out. It'll leave me the liters. And this is in liters, but this wants the answers in mils apparently. So I converted, and it's 6.25 milliliters is the answer. So this is very similar to the problem that